Okay, so this is another word problem. You should be familiar with this one because most of you would have seen it in the first test of 2021. Question 1. Your lecturer is growing a plant on the balcony and observes that the rate of change of height of the plant is proportional to the square root of the current height of the plant. If the plant is 25 centimeters tall when initially measured in late September, and it is 36 centimeters tall 60 days later, how tall will the plant be 240 days after it was first measured? All right, so this problem's a bit of a nuisance because we've got, like we're actually asked how tall will the plant be, right? So we've got to write down an ODE. We've got to solve that ODE. We've got to find the, the constant of integration based on the initial condition. So we've got an initial condition that's fairly clear, I guess. If the plant is 25 centimeters when initially measured, right? We've got this extra bit of information. 36 centimeters tall 60 days later. So at t equals 60, we've been given some information that the plant's 36 centimeters tall, and we're not quite sure necessarily what to do with that first. Let's read the hints. It's always good to read all the information we're given. Aim to write down an ODE with some unknown parameter. So that is, my ODE is going to feature a parameter, or some number that I don't know yet. Write down an initial condition. Yeah, I'm happy with that. I know how to do that. I can solve the initial condition to obtain a particular solution. Again, this hint mentions this parameter, right? The hint then assures me that there's enough information in the problem to find the parameter. And, I should realize that that is this 36 centimeters tall 60 days later. That piece of extra information that I apparently don't need, that's what's going to help me find this parameter. Once I've got the full solution, the completely determined particular solution, I can answer the question that I was asked to solve. Okay, so let's dissect this. I don't know any notation. The question has not provided me with any sort of notation whatsoever. So I'm going to have to assign some. I've got the height of the plant that I'm interested in. I'm going to call that H. Right? I know my height of my plant is changing in time, right? My plant is growing, right? So I know this must be a function of time. So from that, I deduce that my independent variable is time. My dependent variable is height. The other thing that I can take care of is now I can work out the rate that I'm interested in. I've got my dependent and I've got my independent variable, so I can write down dh dt equals question mark, right? And I've got to work out what that question mark is so I can build my complete ODE. Let's go back to the question. The rate of change of height, right? That is dh dt, is proportional to the square root of height, right? The current height. So height as a function of time, height at some particular t. And that's enough information to complete my ODE. The stuff in green says that dh dt is proportional to So we write, we can write this symbol, the proportional to symbol. Proportional to the square root of height. So square root h of t. Okay, when we say that it's proportional to, what that really means is dh dt equals some constant times this. Whenever you see like A is proportional to B, that means A equals K times B. That's what proportional to means. Okay, so we've now got a complete ODE. There's no change, there's no other contributions to change in the height of this plant, right? It's not like I'm pruning it. It's not like I'm doing anything to modify the height of this plant or reduce it. I've just got a positive contribution that says that the rate of change of height is proportional to the square root of height itself. So that is our entire ODE. If the plant is 25 centimeters tall initially, right, so H0 equals 25 is our initial condition. And finally, we note that this K is unknown. And that's consistent with the information in the hint. We've written down an ODE with some unknown parameter, this constant of proportionality, and we're going to have to find that constant of proportionality based on this extra piece of information that we have. All right, so let's proceed through solving this ordinary differential equation. This ODE is non-linear. This is an h square root h, right? You've got h inside some function that's not just like power 1, it's non-linear. This equation is, however, separable. So let's separate. That means we get all the h's on one side, h as a function of t, so we can, that's fine, right? H is the dependent, it's always going to be a function of t. And all the t's on the other. We don't have an explicit t, so we've just got the dt. So we've got k dt here. We integrate both sides with respect to their respective variables. This, the left-hand side's a little bit tricky. Let's rewrite it like this, just dropping the t dependence for now. The right-hand side is easy, kt plus c, where c is a constant of integration. All I've done on the left-hand side is I've just rewritten the square root as a half power. I've noted that it's 1 over square root, so I've put that to a negative half power. Integrating this side now becomes more obvious, right? Add 1 to the power, divide by the new power, right? In a half minus a half plus 1 is a half. Divide by a half. So I get h to a half divided by a half. That's equal to, that's equivalent to 2h to the half. And that's still equal to kt plus c. All right. So I've now got two unknown things to determine. I've got my c and I've got my k. I know how to get c. The constant of integration is just always from the initial condition. So I can knock off c quite easily. Since h0 equals 25, that implies 2 times 25 to the power of a half, square root 25 is 5, equals k times 0 plus c. All right, so that's 10 equals c. Right, so we've got c. We know what c is equal to in this case. Right, so now we have 2h to the half equals kt plus 10. Note that I haven't bothered to rearrange for h yet. You can if you wish, right? It'll just change. You'll get a c divided by 2. So you might find when you go through this problem, if you've rearranged, you'll get different values. But at the end of the day, when we put our expressions together at the end, we'll get the same one if we've done it correctly. We now have to find k. We have the piece of information that h, 60 days after it was initially measured, is 36 centimeters. So we measure it once, it's 25 centimeters tall at time 0. Then 60 days later, it's grown to be 36 centimeters tall. That's enough information to substitute into this expression to find k. So 2 times 36 to the half equals k times 60 days plus 10. So square root of 36 is 6. 6 times 2 is 12. 60k plus 10. So 2 equals 60k. K equals 1 over 30. All right, so I just had to subtract 10 from both sides of that equation and then divide to get my final expression. So my final particular solution is to the ODE, h of t, or 2h of t to the half equals 1 over 30 t plus 10. Implies h t to the half equals 1 over 60 t plus 5. H t equals t on 60 5 squared, like that. I could expand this bracket out. There's no good reason to do so. This is perfectly sufficient. This is a closed form for h, and I was asked to determine h of 240. So let's plug in 240 divided by 60 plus 5 all squared. 240 divided by 60 is 4. 4 plus 5 is 9. Squared is 81. So the plant got to 81 centimeters tall by the end of the growing period.